Bismillahirrahmanirrahim, my dear students. Let's have application area of trigonometric ratios. Here is one example I have considered where the question is we are supposed to find unknown angles now mentioned in right angle triangles. We have two parts here. Let's see how can we find angles, unknown angles marked in right angle triangle. Here, in the same way as normally when we deal for the sides, we are supposed to check according to this angle what sides are given. This angle is mentioning that this is opposite here, and obviously we know this is the longest side of right angle triangle is the hypotenuse. So the opposite and hypotenuse constitute the trigonometric ratio. This is sine trigonometrics that will help us to find this angle. So we will write here, this is sine of A, that will be equal to the opposite, that's 12, and the hypotenuse, that's 26. Now we will divide 12 by 26. Let's write it again. Sine of A is equal to, when 12 is divided by 26, we got 0.4615. You can get this value by operating calculator. Yes, I got by operating calculator. Dividing 12 by this, it can be done manual, but it's a long time, will require time. But just from calculator, divide 12 by 26, you will get this one. Let's carry on rest of process for this angle A. This will be equal to, we shift this trigonometric ratio to the other side, right side. It will be sine inverse of this value 0.4615, my dear. And now with the shift key on your calculator, now press first shift key, then write sine. You will see on the slide there will be sine inverse, then write 0.4615, and when you enter it, you will get 27.5 degree angle. This is the way how can we find angle in a right angle triangle when the sides are given and unknown value is angle. Let's see in the second example. We have this shape given, angle X we are supposed to find here. This side given, according to this angle. Again, we are supposed to assess what sides are given. हमें कौन सी side दी हुई है. So is with respect to this angle, if you look at here, its opposite side is here. This is hypotenuse, so this is adjacent. So in this triangle, we have given adjacent and hypotenuse, and the trigonometric ratio that leads this adjacent and hypotenuse is cosine. Well, cosine trigonometric ratio will help us to find this value of angle X. We will write cosine of X degree, that is equal to adjacent over hypotenuse. This is 10 over 17. We will write it again. Cosine of X degree is equal to, let's write its value in decimal form. This is 0.588 and 2 value. You will get this value by the help of calculator. Divide 10 by 17, you will get this value. Let's carry on for X. We transfer this cosine to other side in a way that we will get X degree is equal to, this is cosine inverse of, this is 0.588 and 2, and finally we will get this angle X degree is equal to, this is 53.9. I have written its rounded value. This is 54 degree, my dear student. This is the way, it's the initial use of trigonometric ratio to find the value of angles. And here you can see sine trigonometric ratio and cosine help us to find respective angle in both parts. Alright, my dear students, let's have another example in application area of trigonometric ratio. This is example number 2, in which we have given this quadrilateral. This A to E, I have constructed this side. Question basically is, we are supposed to find BC in part number 1. this BC is equal to this AE, which I actually constructed as a dotted line. If we succeed to find this, this will be equal to this one. And this length C to D is given as a 7 meter, and from B to A, the length is given as a 4 meter. Now, we need to actually work here in this triangle for finding this angle ADC. This is AD and C angle. This angle we need to find. Here is X degree, we can say. So, first of all, if you see, we can find this length with the help of these two measurements. From here till here, my dear students, this is 7 meter, and from here till here, this is 4 meter. If we subtract this one, cut with this part, and the rest of will be this. So 4 subtracted from 7 will give us 3 meter value here. Now in this triangle, we have given this side, number 1. Number 2, we have given the length of this person. This is given that this length is 7 meter, that I missed in the beginning. Well, this side is given, this side we have, and third one we want to find. This is right angle triangle where two sides are we can see, and third we want to find. We can use, or we are supposed to use even Pythagoras theorem. This square, these are two of the legs, and this is hypotenuse, and this is AE. AE we will find AE squared plus this leg, second one is 3 squared, that is equal to 7 squared, my dear. Let's simplify it. AE squared plus 9 is equal to 49, and this AE squared will be equals to, this is 49 minus 9, this is equal to 40 here, and it's mean AE square equal to 49, it's a 40, sorry, this is 40, I have written 40 here. Let's operate square root on both sides to get the value of AE. Therefore, AE is equal to 6.32 with the help of calculator. Get calculator, operate this one, you will get this value. And we know we have labeled, actually we need to find BC, which is equal to this one. So therefore, BC value has the same as AE, 6.32 meter is the value of BC. 6.32 is the value. Now, the second part, ADC, we are supposed to find this angle. If we look at this given values, yes, all three values are available. We can use any trigonometric ratio. But I only consider this one. According to this angle, this value is adjacent. This is hypotenuse. Adjacent over hypotenuse is the cosine trigonometric function. Our focus is to find this angle. So my dear student, this is cosine of x degree is equal to 3 over 7. And this x will be equal, cosine instead we need to write again. And this is equal to 4, it's not 0. If we divide 3 by 7, this is 0.4286, my dear students. When we divide this with the help of calculator or manually, we will get this value. And now this x degree will be equal to cosine inverse of 0.4286. And therefore, x finally, now use the shift key on your calculator, operate cosine inverse on this one, and finally you will get this angle 64.6 degree. When you operate inverse function on calculator, this value, you will get this angle. And now, these two things we actually have to find in this given figure. Alright, my dear, keep it up, keep on revising, revise it again, so that you strengthen your concept of learning use of trigonometric ratio. Alright, my dear students, let's have another example, which is application of trigonometric ratio. Example number 3. Here we have a triangle PQR. in which we are supposed to find two parts, angle QPK and length of QK. Here is the picture given. This is triangle PQR, in which here is a point K given. This is a composition of two triangles. In fact, the three triangles, two right angle and one is this additional triangle. The question is, we are supposed to find this angle QPK. This is our target, to find this angle. And we have given information. This is hypotenuse of the larger right angle triangle is given. This portion QK as the length we are supposed to find. This angle 137 is given. So, and this height of the larger triangle is given. This is 7.6 centimeter. First of all, we will work for QPK angle. This is QPK. For this purpose, we are supposed to find QPR first, and that will help us to find this angle. So first of all, let's focus on the larger right angle triangle PQR, in which we have given this one side and this side as well. If I want to find this angle first, for example, so according to this angle, this is adjacent and this is hypotenuse. So adjacent and hypotenuse tells us that there is trigonometric ratio of cosine. So we have cosine of QPK. This is equal to adjacent 7.6 over this value. This is 7.6 over 17.4, and this will be equal to 0.436 and 8 when we divide on calculator 7.6 by 17.4, we will get this value. This is cosine of QPK angle, and it's a QPR, sorry, because we are considering this QPR, this total angle we are considering here. So it's a QPR instead of K. This is K. Here is R. QPR. So QPR will be equal to cosine inverse of 0.4368. And when on calculator we will operate this value, we will get the angle 64.1 degree. This angle here, QPR, this total angle is 64.1. And our target is angle QPK, this angle. This actually we need to find. For this, we will move this angle. This is 137 here. And we can get this angle because straight angle is 180. If we subtract this 137, we will get 47 here. This is, you may get this by mental calculation, but you can show even that this angle is equal to 180 minus 137. 180 minus 137 gives you 47 angle. Yes, this gives you 47 degree. This is 43, sorry. It will give you 43 degree angle. Yes. When we subtract 7 from 10, we will get 3. And then we subtract 13 from 17, we will get 4. So 43 angle we got here. We want to find this angle is 43. It means this angle would be, we know that in a right angle triangle, if one angle is 90 degree, the rest of two angles also it's the same 90 degree. So if we want to get this, we will subtract 43 from 90, we will get this. This will become, the meaning is this. We will subtract 43 from 90 degree angle. Again, this is 90 minus 43. This is equal to 47 degree. subtracting 3 from 10, we will get 7, and then subtracting 4 from 8, that will give us 4. Now we got 47 here. Our ultimate answer is this. From this total angle we have found here 64.1, we will subtract this angle to get this one. So therefore QPK angle will be equal to total angle 64.1 minus 47, and this will give us, this is 1 with the decimal, and 7 from 14. When we subtract 14 from 7, we get this one. Remaining 5 is here. Alright, subtracting 47 from this gives you 17. From 0 from 1 we got 1 decimal as it is, and now subtracting 7 from 14 we got 7, and now here is 5 left. Subtracting 4 from 5 we will get 1 here. This is 17.1 degree is the answer for this part that actually we need to find. This is QPK angle, that is the part 1. My dear students, look at here. In the beginning there were only this side and this side are given. With the help of these two, my focus was to find this whole angle and then move this angle towards here, and when we subtract from whole angle this angle, we got the target required angle that was mentioned in this part. Now let's move towards the second part, the length of QK we are supposed to find. This is QK length, this is we are supposed to find. And we have given information, this one side 7.6, this 17.4, and this we're going to find. We have two choices. We can move with trigonometric ratios, but we can use Pythagoras theorem. Any method from these two can be used here to find, to move this part actually. This part can be calculated. I have assessed here, first of all, we will find this total length, and then we will find this length equal to RK. To find this x centimeter, that is QK, we will subtract this portion of length from this total length. The remaining value will be equal to x. What I did, I'm going to label this one, let this is A, and let this is B. So we will find the value of A and value of B. This A from the larger right angle triangle, and this from this small right angle triangle, and to get x, this x will be equal to A minus B. So let's work for A first. In the larger right angle triangle PQR, where one angle we have found, that is, I should mention here, this angle 64.1 degree we have found. It can help us because according to this angle, this is opposite and this is hypotenuse. We can carry like this, for A over 17.4 is equal to, this is sine of 64.1, and this A length will be equal to 17.4 into this 17.4 into 64.1. We got the value of sine of 64.1, that is 0.8996, and now we will multiply this with the 70.4, we will get 15.7 centimeter. Almost this part is same as we did in previous beginning examples. Opposite over hypotenuse, that is equal to sine of respective angle that we got here, and then it's a simplification. Use a calculator for the value of this angle, getting the value of this angle, and then multiply these two terms to reach up to here. This is the value of A. We have found A. Now our focus is to find the value of B. Here is the B. In this triangle where 43 angle is here and this side is here, we can find this side. This side and this side will help us to find this value. We can use this angle as well. It's a totally depend on what actually you want to write the ratio, and that trigonometric ratio will have to carry on this calculation for the value of B. Well, if now focus on this right angle triangle, and if I want to consider this angle 43, its opposite is 7.6 and adjacent is B. So we will carry this question in a way that this is tangent of 43 is equal to 7.6 over B. Let's transfer this B to this side, and tangent of 43 on this side, B will be equal to 7.6 over, this is tangent of 43, and this is equal to 7.6 over tangent of 43 we will use here. Alright, my dear students, let's have example number 4 in the area of application of trigonometric ratios. We have this application in the form of word problem where a point P on level ground is 34 meters away from the foot Q of a mango tree TQ. Here is TQ mango tree, and this is 34 meters away. A point is there, and when I have drawn it's become a right angle triangle with, if this PT length, this one, if this PT makes 32-degree angle with the horizontal, find the height of the mango. This is mango tree, this is our question. So I have drawn a mango tree here whose height is we are supposed to find. Let this is x meter that we need to find, and TP making angle 32 I have drawn here, 34 meters away from the foot Q this point is. So let's solution for this word problem. Whenever, my dear student, you got word problem, try to understand what the values are given. Given values को लेबल करें, जो खाका दिया जा रहा है, the picture that is explained here in the word problem. First of all, draw that figure, label the given all these values, and in the application of trigonometric ratios, figures almost all the time give you a right angle triangle because you need to use trigonometric ratios. So again similar, so we got right angle triangle here and with some known values, and this value we want to find. Now if we focus as a figure here, as I explained earlier, that first of all we are supposed to analyze what sides are given. This is angle, and opposite to this side is opposite here according to this angle 32, and this is adjacent. And now we will think adjacent and opposite give what trigonometric ratio. So that will help us to find the value of height of this tree. Now here if I consider height x centimeter, so x opposite over adjacent 34, this will be equal to tangent of this angle 32. And then to find x, what will we do? We transfer this, cross multiply to the other side. This will be 34 into tangent of 32. Now we will write the value of 32 here with the help of calculator. Write the value of tangent of 32 and we will get 0.6249. This is the value of tangent of 32 from the calculator. And now multiply these two values. Again, you may multiply manually, but you can get help from calculator as well, and you will get answer. This is 21.2 meter is the possible height of the tree. Therefore, height of mango tree is equal to 21.2. This is 21.2 meter. So, my dear student, you see this working is almost similar as we did some example, but actually skill that you need to develop is try to understand what the values are given and what picture actually he want to make you draw first, and then follow the instruction, follow what you are supposed to find. Try to understand what is given and what this whole concept can you to draw the picture according to that. Draw the picture according to that, and then understand what figures and angles are given. According to angle, define the sides and then pick the trigonometric ratio and carry on calculation. You can find your unknown value. Right, my dear students, here we have one more example from the word problem area of application of trigonometric ratio. Here we have example number 5. A board is tied to a rope of length 14 meter that is attached to a ring which is 4.5 meter above the water level. If rope is taut, then find the angle which the rope makes with the water. The angle which rope makes with the water. Now, with the given situation and the information, I have drawn this right angle triangle. Here, this is the high level where the rope has taut, and this height is 4.5 meter given in the question, and this rope, length of this rope is given, this is 14 meter. We have question that we are supposed to find this angle made by rope with the horizontal level. That's the level of the water. Here is the water level, and that angle we need to find. As I told you, so when this figure completed, जब ये figure बन जाए, figure completed, we will focus what information given according to this angle. It's opposite here, and this is hypotenuse. Opposite and hypotenuse give us a trigonometric ratio, that is sine, this is sine x, equal to opposite, this is 4.5 my dear, and this is hypotenuse, this is 14. Now we will carry on rest of calculation as we were doing in all questions, and here x is equal to, this is sine of x, sorry, let's have its decimal value. When we divide 4.5 by 14, we got 0.3214. With the help of calculator, divide this number by 14 and you will get 0.3214. And then, because our focus is to find this angle, we transfer this trigonometric ratio to the other side. This will be sine inverse of 0.3214. And then again, now with the shift key we will operate calculator to get this angle sine inverse of this. This will give us 18.7 degree angle when we operate shift key. Then write this value sine and it will show us sine inverse. Then we write 0.3214. When we enter it, we will get 18.7 degree angle. This is the angle made by this rope with the water level. That is the way to handle these word problem. Focus on developing understanding skills about the word problems. If we could understand correctly the word problem, what type of shape is possible and where are the information, and the rest of part to handle this, manipulate this figure is too easy. Just write trigonometric ratio and then simplify them. We will get the answer that is required in the word problem. That's it, my dear. This is all about today and the trigonometric areas from basic concepts to the application. I have tried to elaborate the basic concepts, then use of trigonometric ratios, and then application of trigonometric ratios. Keep it.
डियर स्टूडेंट, सब्सक्राइब बटन और बेल बटन को दबाएं ताकि मेरे वीडियोस आपको सबसे पहले मिल सकें।